time step, you know, is it a uniform time step? And then I've had a look for the missing data, and I've put what's the gaps in a little summary table here. But I'll just show you how I checked for the missing data. So this is the data as it was downloaded, but then I've added in this column here with the blue font here where I've just put in the first date and then I've filled down. So you can get monthly in Excel by just writing November 1993 and then just get it to fill down. And Excel is clever and realizes we're talking monthly, and it's just done a monthly step there. Or you can also do a couple of dates and then highlight it and copy down to get Excel to sort of understand if you're doing daily or monthly. So I've just put in the date here, and then if you scroll down to the bottom, you can see they don't line up. So I've put in another column here with a formula to check for the missing data. So I've used an if statement, and I've also used these functions year and month. So if you do the year function, you can just go equals year and you put it on whatever date column you have. This function should just return the year. So it pulls the year out of the date. So it can be a handy function for various reasons. And the same with month, it does the same thing, it pulls the month out. So I've used that, and I've also used an and statement. So the and just means that both of those conditions need to be true. So I'm checking if the year in column D is the same as the year in column E, and if the month in column D is the same as the month in column E, then if both of those, if they're matching up, then just put a blank. If not, then put a 1. So it's just a formula to try and flag for where the missing data is. And there's probably different formulas you can use and different ways you can check. This is just the one way that I thought of, and you can probably think of a better way. But if we scroll down here, you can see here the formula is flagged with a 1, that it's not matching up. So in this case, our months and our years wouldn't be matching up because we've got this huge gap in the data set here from 1998 to 2005. So the formula is just helping to show that up. And then, you know, you can use your formula and perhaps reset it to continue on down and see where the dates aren't mixing up. So in this case, I've just kept that there to show you, and I've done another column where I've started from October 2005 and put another formula in here to just check, okay, so where is the next missing gap, and I've just highlighted that there. So you can visually have a look for gaps, but it's really easy to miss them. Even if you're staring at data, it's easy to miss that perhaps September isn't in there. So it's useful to use some sort of formula to flag the gaps for you. I did that for both of them. Yeah, I'm not sure if anyone has a different way they can think of or suggest to the class a better way they might have done it. You could potentially just say, does my date in my checking column equal my date from my downloaded data? Just simply say, have a look, does that equal that? And you might even get just a true false answer in Excel. But in this case, because the downloaded data has a minutes and hours attached to it, and that varies, I couldn't create a column in Excel that could match that. So that's why I just checked on the year and the month.
Hey, Emily. So I just did a pivot table of the dates and did a count. And that shows up like what years have missing months, because like
that's clever.
For example, 2005 only has 3 counts in it, whereas the other years have 12.
That's a really good way to check as well. That's awesome, Tom.
Yeah.
Yeah, that's a really clever way to get a really quick overview, and then you could easily then pull your summary from your pivot table and make that into something you put into a report where you're showing the gaps. So I sort of manually was looking at the gaps and readjusting my formula. So that way is probably even better for a big data set and for giving you a quick summary of where the gaps are that you can put into your report when you're reporting about the quality of the data. That's an awesome tip. I didn't even think of that.
Yeah, that is a pretty clever way to do it.
How do you do it then, Tim, when you're doing your big flow data set?
I was actually using like a VLOOKUP function.
Yeah, that's such a handy function, VLOOKUP.
Yes. So basically, like so basically what I did was that I take, because mine is a minutely data. So from the raw data, I made a column like this is the raw data, and then I just added another column beside it, like the timestamp. So like each row below is like plus 1 minute above of it. So I will be able to check whether it tallies or not, like at the end. Yeah. So if it doesn't tally, okay, then I will just use I'll just make a text format of the timestamp first, because like timestamp is actually a decimal number in Excel.
Oh yes, yeah.
Yeah. So what I want them to match is the actual date itself, is the actual date and the time. So I just put them in text format. So I just try to use VLOOKUP to match the text format of the time, and then if it matches, then transfer all the data into its separate into its own cell. And so if it cannot find the exact data, then it will just output like hashtag NA.
Yes.
Yeah.
And then what do? You have to manually go in for each of those, or
no,
it's just missing.
So for those NA, I just have to like filter, and then I can just click on the ones with the NA, and then and then it will just pop everything out, and then I'll be able to edit. Yeah, I can copy the entire table into another spreadsheet to identify those missing timestamps. It's pretty handy.
That's really clever.
Yeah.
And a lot of work. But...
Yeah, a lot of work. and also like VLOOKUP is pretty resource intensive. So it it has a high tendency to crash a computer.
Yes, yeah. It's got to do a lot of processing. Yeah. It's I think it's often the most time consuming part of any project is preparing the data for use, and then analyzing it or running a model often can be less time than this like data checking and getting it all ready.
Yes.
And you don't know what format you're going to get the data in from the client. It could be just such a mess, and you've got to sort of spend a lot of time fixing it up, checking it, infilling gaps if possible. Yeah. How's everyone going? Going okay. So after I did that step, I then had a separate worksheet where I reinserted the missing dates, because I was finding for doing, for example, a check of the proportion of my data with each quality code, which was also an example given in the week 5 lecture that could be really useful for your assignment too. Trying to find the slide where we had a table where we had the proportion of the total data set for each of the quality codes, and it gives you a good visual assessment of the quality of the whole data set. So I just reinserted, I'll share my screen again quickly, but just ignore, guys, if you're just keeping on working. I did a separate spreadsheet here where I've reinserted the dates that were missing. So for the missing dates, I just put in quality code 255, which is the missing data quality code, and then did a table here where I've got the quality codes in here, and I've just done a count if function. The count if function just looks at the column of the quality code data, and then it looks at each quality code in turn. So count if it's quality code 1, to just get an idea of how many data points are quality code 1. But when I first did this in a hurry, I hadn't reinserted my data. I was checking the amount of quality codes within the data set, just the data as it came, and it meant that it showed there was no missing data. So by reinserting the missing dates, you can do this analysis and see that there is quite a high proportion for this site of missing data. And then it means that we can get the two data sets side by side for comparison purposes as well, which can help.
And for those that are wondering, like where, like how do you generate this table, you all can refer to the week 5 water quality analysis slides, slide number 18.
Oh, thanks, Tim. I hadn't located which slide it was yet.
Yeah, slide number 18. I just looked for it. Yep, this one.
So this one here. So it gives us a good idea how much good data there is, whether there's any kind of suspect, higher suspect data that we have data for, but it's a bit of a dodgy quality code where it's, you know, unknown quality, like QC code 180, for example. And we can see how much of the proportion of our data set is each of these, and how much is just totally missing, like that quality code 255. Yeah, so I think countif could be a helpful function to try and create that. And then you can work out the proportion just by dividing by the total number of data points that you have. And then this column for missing data that was given as an example in the lecture slide, that's just where you're indicating to your data user which of these quality codes you've decided to say is missing. So in this case, we actually just have no data for that quality code 255. So obviously all of that's missing. If we had some suspect data of these higher quality codes, like quality code 150 perhaps, we might look at whether that's appropriate for use, and we'll either decide to use it or we might deem it missing data.
Or maybe you should check on like where are the students currently at.
Good idea, Tim. Yep.
Yeah. Okay. So everyone. So can I get a hand of those who have completed task 1B? Those who have completed task 1B. So can you just put a like reaction or something if you have completed that? Just to gauge, just to check on your progress.
That's a good idea to use the reactions. I should try that a bit more.
Yeah.
In lectures and in the prac class. That's a really good idea. Okay, so maybe no one's oh yep, Hans put his hand up.
Yeah, so hard.
Maybe not too many people are up to that stage. It does take a while to check the quality of the data. I think that's probably the most time consuming part. I think that the time allocation on the prac task is a bit wrong there. I think task 1 probably takes a lot longer than task 2 and 3.
Yep.
Does anybody want to share, just even in the chat, any of the methods they're using to have a look at their data set? Thanks, Hans. So Hans completed that.
Yeah, so perhaps you want to share in the chat box, or do you want to open mic and just
No, I didn't finish I just finished to check the data. I didn't finish to put the data because I'm using Emily's way to check it, and it really takes time to put the data from one data set to the other. Like I'm summarize the raw data to data for analysis.
It does take a little bit of time, yeah. Let us know if you need any help with any of that. There could be better ways to do it as well. You might think of like Tom's way, using the pivot table.
Hey, Emily, do you want us to infill the missing time steps?
It's a really good question. So we talked about infilling, but a lot of the methods we talked about were really simple and mainly good for short time periods. So for the purpose of this prac, no, we don't need to. Mainly, you might want to infill if it's really important for your analysis of the data. Like if you're putting it into a model and you've got gaps in the data, then it's going to stuff up the model, then infilling is a good way to be able to make do with the data, as long as you report what infilling you've done and you use appropriate methods, like you're not infilling across the top of what's naturally maybe a peak because it's a storm event in your water quality data, and you infill and you flatten that with just linear infilling, for example. So what were you going to say, Tim?
Yeah, I was trying to say like it also depends on what are the parameters like it depends on the parameters that you are trying to infill. So let's say like for flow data, so sometimes you can infill, but most of the time you just try to leave it empty because because there might be a gap. There might be a huge gap right there. You might miss the peak for the storm event. But for other parameters such as like for water temperature. So let's say if you have let's say like at like an hour of gap, like provided you are like, for example, if you are using like 6 minutes time step and you have like an hour of gap, I think it's okay for you to use a linear interpolation, because you wouldn't expect the water temperature to spike up, to spike up or go down like dramatically. Yeah. So I think in that instance, you it's good to use to infill the data.
Okay.
That's a good point.
What about the actual time steps themselves? Do we leave them as is with the missing time steps, or should we infill the missing months and just leave the data blank?
Yeah, so I did that. I inserted the missing time steps like in a different worksheet. I did, because then it meant I could sort of line up the data side by side. And for doing that summary table of the missing data, if you do that just without the missing time steps, it's deceptive and it tells you that there's no missing data, it's all good. But if you reinsert the missing time steps and put missing data, then that will allow you to make up that table and calculate the proportion of missing data, for example.
Yeah. Okay. Cool.
That's a really good point. And just more on that infilling. So see how we've got that gap from 98 to 2005. It'd be really difficult to reliably infill that. For longer gaps, you can use regression analysis, where you might have data from a nearby station, you develop a correlation, and then you use that relationship to get data. But infilling for such a long period, that would be have a lot of uncertainty with it. So probably in that case, someone asked me this morning, what would you do then if you had a gap? I think you'd have to either not use data from that station in your model, or perhaps just use the periods that you do have enough continuous data over in your model. And any little periods like a missing month, you might be able to look at whether infilling would be appropriate. And plotting up your data like a time series can give a good indication of how much variation there is there, and whether it could be appropriate to infill. Here's the question. Can we explain what are the objectives that are necessary to be checked for data quality checking? So quality code, time. Yeah, maybe I'll share the screen with the week 5 slide on that. So I think you're asking what kind of checks we need to do. Is that right? Or is it why it's important to do these checks? Hang on, I'll just check. I just missed that last comment, but I'll bring up the PowerPoint. So some of the things that it's good to check. What slide did I say it was on? Slide 15.
It starts at 15 or either 11.
Oh yeah, 15 I think. Sorry, some of them are grayed out because we worked our way through them in the lecture material, but having a look at how much data we actually have, the start date, the end date, the units, as I mentioned before, really important to know exactly what units and not make an assumption. And particularly for certain water quality parameters that can be measured in different units, like conductivity, for example. So salinity data can come in a number of different units. Time steps, and make sure you check if the time steps uniform. So it looks like we've got monthly data here, but you could have a data set where measurements were taken more sporadically. There could be sometimes 2 measurements a month, sometimes 1 measurement every 2 months, for example. And particularly with water quality data, because it's always more sparse. We have less of it than the flow data by a long way. So very often water quality data, if you're lucky, it's just 1 monthly sample where someone's gone out to a stream, filled a jar, and then that's been analysed. And if you think about how much water quality can vary over time, particularly with storm events, with high flow events, going out once a month, we're going to miss a lot of the peaks. We're probably not even going to capture many of the storm events in our time series at all. So it's important to keep that in mind, and we'll talk more about that when we talk about monitoring. Yeah, so checking for missing timestamps, that's what we've been doing by inserting our own date column and checking if it lines up. Having a look at what gaps there are, having a look at zero values and checking if they're really zero values, or if sometimes you might receive data from an agency where they've used zero to indicate missing data. So just having a bit of a look if it's genuine or not, and having a look at the quality codes, which we've done for the flow data as well. And just where the data's been infilled. So sometimes, and plotting the data can help tell you that. You might see really artificial part of the time series where it's got, you know, a slope because it's been linearly infilled, but there might not be any quality code telling you that, and it might look like it's genuine data when it's actually been infilled by someone and they've sent you that data as if it's the raw data, but it's not. So that's just some of the checks. And then, you know, making these graphs that we talked about, like box plots, comparison. So, you know, in this case, we've got data from 2 sites, so you can make a box plot to compare the data you've got from the 2 different sites. Someone was asking me this morning, when would we use this comparison here? We talked about in the lectures where we're plotting up all of our data, then we're plotting up our good quality data, and we're plotting up our suspect data. So in this case for our data sets, we don't really have any suspect data. We've got fairly good quality data, or we've just got totally missing data. So in that case, we can't do this comparison here. But if you had some data where you don't know if it's trustworthy, it's got a high quality code, it looks suspect from its quality code, you can use an investigation like this, doing a box plot comparison to have a look at, okay, what's the range of my suspect data? Does it have a similar range to all of my data, or does it tend to be all low values and it could potentially skew my analysis? And this comparison doesn't tell you in itself whether you should actually use the data or not, but it just gives you a bit more information about the impact that suspect data could have on your results. If it does look like it's got quite a different distribution and it could affect your results if you include it versus excluding it, then it's good to do the analysis with and without it. So I hope that's not sort of gone too off topic, but it was a question this morning of when would we do this analysis. So not really in the case of the data set we've got today for the prac activity, because we just don't have any of that suspect data, but you could potentially for assignment 2. It's a useful comparison. I hope that answers the question. Anybody stuck, having problems with Excel? So I know this morning a few people had trouble getting like even that year formula I showed to work because their dates were in a different format. Thanks, Tim. So if anyone's having trouble with that, we can look at it. Also with water quality data, you can often get data that's below the detection limit. So that's because when we're measuring water quality, many parameters, you take your sample back to the lab and it's analysed using lab processes and equipment to analyse the concentration of that parameter, and that equipment will have a detection limit. So a point below which it can't detect really low concentrations. And it depends on the lab you're using, on the procedure, the analytical procedure and the equipment they have for that sensitivity. So how low they can detect that parameter, so phosphorus. And so very often you'll get data coming back from the lab that says less than 0.05, which is the detection limit for that parameter, for example. So you need to check your data set for that, because obviously you can't calculate a median or plot up data that's in a form of less than 0.05. So in that case, people make some sort of assumption, and they might set the data that's below the detection limit to be the detection limit. So they might make all of those values equal to 0.05. Sometimes people set it as half the detection limit. But whatever approach you use, you just need to report that when you're in your report alongside your results, so people interpreting your results know what you've done.
Hey Emily, can I just ask about if we have the missing data, should we put zeros into the blankets or just leave it blank?
That's a really good question. So I definitely wouldn't put zeros, because that can be confused with genuine data. So it could look like a concentration of 0, for example. So even though I said you need to check the data set for any zeros that might have been put in to flag missing data, I don't recommend it as something that you should do. You should check for it, but definitely don't put zeros in. But it's a really good question. And you can put in something like -99 to flag it, like what we did for the flow data. And that can be what you do if you put it into a model. But in this case, we're trying to do plots and statistics and things. So either you could do 2 columns, or it might be better just to set it as a blank, so that it doesn't skew your calculations of any statistics, and it doesn't plot as a -99 either. So it's a good question. Usually it might have multiple columns with different flags depending on what you're doing with the data.
Yep, thank you.
Yeah, it's a good question. What do you think, Tim? What do you normally flag missing data as?
So usually for missing data, I just leave it empty.
Empty? Yeah.
Yeah, I just leave them empty all the time. Yeah.
If you're using a formula and it's got a formula in it, though, Excel sees that as something, and when you're doing your time series plot, it plots as a 0.
I just
and
like for yeah, I just put an A. Like
yes,
that are empty. Yeah, so when I'm
and then you set your plot to show that NA is what missing data is then. Yes. Which is what we did back in week 1. I remember we were talking about how to get the plot to ignore that data.
Yeah, actually, like if you put like NA, and then it will just automatically just just not shown on the graph. I think it was your method. Yeah.
Oh, I think Andreas, the lecturer in Malaysia, showed me how to do that actually.
Oh.
Yeah, I didn't know previously.
Yeah, it was a pretty cool trick, you know.
Yeah. I didn't actually do that myself when I was doing the solutions to this prac, and I noticed my time series plot is plotting the missing data as if it's 0. So that's not ideal, and I haven't done it.
Yeah, so like if you leave it empty, so they will plot like everything on 0. Yeah.
Yep. Unless you actually go back to your column and you delete the formulas from those rows so that they're just totally empty cells.
Yeah.
And then it will plot it as a gap. But that's time consuming and manual. And
yeah, and if you use like scatter plot, like that wouldn't work. Like they will just interpolate the whole thing, like the missing data. So if you use like scatter plot with lines.
Oh yes,
yeah. So if it's a line, then it will just interpolate. Yeah. So if you want to make it like really empty, so I think the good way is to use like a scatter plot, or like just scatter only.
Oh, and not have the lines connecting.
Yes.
Yeah. But then for time series, I think it's hard to see them when a scatter plot, but maybe you're right. So it's got no interpretation on the differences between the points. Yeah, I usually always use a line connecting for the scatter plot, but that could be a good way to try and make sure it's not plotting things it shouldn't.
Yeah, but I think actually it depends on like it depends by case actually, because mine is a minutely data. So even though if I use like scatter only, like because of the number of like the scatters, it actually forms a line, like
Yes, it would. But then because you've got such a small time step and you've got so many points,
yeah.
so those points is quite bulky, isn't it? So you probably can't see. Whereas if you use a thin line, you can see the differentiation a little bit more of the pattern.
Yes, exactly.
How's everyone going? I'd really love to know if you're a bit stuck and you're wondering what the hell we've been talking about. You're not sure where to start. I really want to be able to help while we're here. I think you can even send anonymous messages, can't you? I don't know how you make it anonymous actually.
Like a private message, I think.
You can do private messages yet?
Like in the chat box there's like two, and then currently it's like everyone, but I can just just click on like anyone and just send a message.
Oh, good question. Is there an example of a cumulative extents plot for reference? So yes, there is. In the resources or the references folder, I've forgotten what I called it on Moodle there for the prac activity, there is an FDC example. I'll share my screen and just show everyone as well, so you know what I'm talking about. That was done by Tony Labson. So this is FDC for flow duration curve, but it's a cumulative exceedance plot just for flow, and we can use it for water quality data as well. But the thing is, this is done with the plot on a log scale. Because of that, Tony, and see how he's got a comment here, he's made the minimum 0.01, and that's because you can't plot zeros on log scales. You might find a log scale is the best for your water quality data sometimes. In this case, though, it doesn't plot very well on a log scale because we just don't have that type of range of values. They're more within a fixed, smaller range. So it's better not to plot on a log scale. So you can just change this formula here to get rid of this if statement and just use the percentile here because we don't need to cap it at 0.01, and it just means that the bottom end of the curve might not plot very well because we've got a few phosphorus values that are less than 0.01. So you can just change it like that potentially. And what I did was just copy Tony's the way that he's calculated it and his plot and put that into my Excel spreadsheet here to get it to plot. But you'll probably do better than me. When I used Tony's plot, I couldn't get the x-axis to plot down the bottom. It just insisted on being up the top. And students found the same this morning, so they just sort of made their own plot from scratch so they didn't have that problem. Hope that makes sense. But that's an example you can use to get your cumulative exceedance plot working. Sophie?
Yeah, can we get a hand of like can we get some comments on like where are you guys currently at? Like which task are you guys at?
That would be handy. And if anyone's having any trouble.
Yeah.
So it took me a while doing it when I was having a go at doing it. So don't feel like you're slow. I don't even know if I got it done in 2 hours necessarily. So this morning, I think when we came back to talk as a class discussion, everyone was sort of only really just up to task 3, I think. So, and probably not everyone. So trying to do the quality check. Okay, yeah, it is definitely time consuming, but so important. And I know it's also quite dull, this type of real trawling through the data. You have to be quite meticulous. It's not super exciting like putting something into a model and having a look at what results you get. You kind of can't wait to get to that next step, do something with the data, but it's really valuable work to put in as a foundation to make sure you can be confident in your results and not have to repeat things, or worse still, tell someone who's using your results that there was an error and it's wrong, and you're going to have to give them a totally different result, and maybe they've gone off and started spending money based on your finding, and that would be just really horrible. Can we use Aquapac to do a spell analysis to check the total phosphorus concentrations? That's really interesting and a good question. I've never thought of using Aquapac, and I've only really heard of spells analysis for flow. But yeah, I think you potentially could have a look at it. Yeah, so I think it's generally used for flow, that spells analysis, because you're interested in having a look for any streams that go dry and have zero flow. Having a look at zero flow spells can be a really important indicator, and having a look at how frequently they're occurring, for how long. And then also you might be looking at over a certain threshold, because that's important for your management of the stream, or perhaps that's a threshold where you can take water out of the stream, for example. So that's why the spells analysis is so useful, to tell us when conditions of flow are above or below certain values. And I think water quality parameters fluctuate. Well, they're all very different in the way they fluctuate through time. And some have quite a strong correlation with flow. So when flow is really high, there's a lot of transport, particularly of sediment and any pollutants attached to that sediment. So you'll see a lot of similarity in the patterns in the data being correlated with flow. So I suppose you could use Aquapac. Yeah, potentially, and that could be useful indicators for ecosystem health. Having a look at, for example, dissolved oxygen, having a look at when and for how long dissolved oxygen levels dropped below a certain critical threshold, where you might start seeing stress on the ecosystem, where fish can't breathe anymore because dissolved oxygen is too low. So it could be a really interesting idea, actually, using a spells analysis to illustrate that. I can't see why Aquapac wouldn't necessarily work for water quality data, as long as you made clear to anyone reading those results that it was for water quality and not for flow. It's a really interesting thought. What do you think on that, Tim? Anything?
I'm just trying to check whether Aquapac supports like water quality data, because usually it's being done for the for flow data, and like it's a daily data.
Oh yeah, that's interesting. Yeah, I think Aquapac you could. I didn't think about the time step. We don't often have daily water quality data, unless these days now you've got in situ sensors, so probes you can stick in the stream, and they can only measure certain parameters, usually the physical parameters like temperature, EC, dissolved oxygen, but that's when you can get higher frequency data on like a minute scale, and that's when we've got lots of water quality data. But historically, it's generally been the monthly samples. So that's interesting. I thought Aquapac you could, you have to specify your time step.
Yeah.
Because my computer died this morning, I'm using one that doesn't have Aquapac on it, so I can't actually look that up. But it's a good question and good thinking of the time step, Tim. So if you could maybe put monthly data into Aquapac, maybe you could. But then, because if you're looking over a longer time step like monthly, there's less kind of autocorrelation there between values. So AquaPack and spells analysis kind of only really works on a shorter time step. I think it only really makes sense because you're looking for periods and for how long the periods have been where it's been above or below. But if we've got data only on a monthly basis, we don't know what's going on in between those monthly samples. And it could very well, the values have fluctuated all over the place in the meantime. So doing a spells analysis on monthly data probably isn't very meaningful really, because you don't know that what the data was doing in between those monthly readings. And so you can't sort of say, oh, for 3 months it was concentrations continuously above or below this threshold, because it's quite likely that it's changed in between your readings. Even if your 3 monthly readings are particularly high and above a threshold, you don't know that it hasn't dipped down in between, I think. So that's a really good point, Tim, to think about the time step. And I think you're right. I forget that this is monthly, and it wouldn't really make so much sense.
I mean, like you could aggregate like daily data into monthly data, but I don't think that works for water quality, like some of the water quality parameters. Like it's like you can't aggregate aggregate total phosphorus value.
Yeah, no, I don't think that makes it wouldn't make good sense. I mean, you might aggregate flow data potentially, but yeah, you can't just aggregate it like that, especially when it's a concentration. You'd need to convert it into a load or something. Yeah, no. So I think it's a good point. Thanks, Han. Good thinking. If you had a shorter time step, you could do some sort of analysis like that. But yeah, I think not the monthly. Thanks, Tim. That's good thinking. So does anyone need help making any plots in Excel or anything like that? Like, I didn't know till recently that in newer versions of Excel you can make box plots, which is great. You told me that, Tim, I think.
Oh yeah, I think it was like 20. I think it started to be released at late 2017.
Oh really? Yeah. All this time I didn't think you could do it.
Yeah.
And that was really frustrating that Excel didn't do box plots.
Yeah, okay, so I received so an anonymous question. So if there is a missing data, so do we just let it be, or we just put 0 right there? So I think for this one, it actually like, of course we don't put 0, because it's missing doesn't mean that it's 0. But then you can choose to interpolate interpolate data, or if not, you can just leave it empty. Yeah, and it depends on several factors, like like what are the parameters that you are trying to, like you are looking at, and then probably like how huge is the empty gap, and so on. That but I think these two are the main factors.
That's a good point, Tim. And I think in this case, because we've got monthly data, probably we shouldn't interpolate, because that's a big time step. We're not talking about trying to just bridge a couple of minutes or even a day. It's a month. So especially using the simple means like linear interpolation, you could do regression to develop a relationship with a nearby site to fill in monthly data. But yeah, I think not those simple methods we talked about in the lecture. But yeah, that's a really good question. And I recommend do not put zeros for missing data, because it looks like it's a concentration of 0, and it's just will be confusing, and you'll be doing your analysis and calculating your average or standard deviation, things like that, and those zeros will be skewing your result.
And also I think like this is a very good question, because it really impacts the outcome of the assignment 2. Yeah, because assignment 2 you will be dealing with all of this. Yeah, so it's really like a decision, like a decision, and probably you need to really think about, like, is it better for me to go for infill or leave it empty? Like that is a very key decision that you have to make in your assignment too, because that will affect your modeling results.
Mm-hmm.
Yeah, just a sneak peek.
Sneak peek. Yeah, so I would leave it as a blank in this case for your analysis. And if you needed to put it into a model, which we're not doing in this prac, you then might look at putting a flag in like the -99 or -999, depending on how the model likes to be told about missing data.
Yeah, so far anyone is having problem with the like the cumulative accidents plot? Any of you, if you are stuck anywhere, just feel free to ask.
Mm-hmm. Maybe I'll just share my screen and show some of the plots that I made. Just ignore though and keep working if you're not interested in having a look at that. So you've probably done some better plots even, but so I did that table that I showed you summarizing the proportion of different quality data with the different quality codes. And then I did a box plot. Your box plots might look a bit better. You can see a lot of the data is really very low values, and then we've got a fewer higher values, which is pretty common with our water quality data. I just did a comparison there of the two sites. I did a time series plot, but you can see from my time series that big gap here at that Valencia Creek site between 1998 and 2005, my graph's actually plotting that as 0, which is not ideal because it looks like it's 0 concentration when it's actually missing data. So if I wanted to fix that, I could go back to my data where the plot's looking at here. So I reinserted my missing data, and this plot's actually look at this column here where I've just used a formula and I put nothing if it's missing. But if I don't want it to plot on my time series, I could just manually highlight that and delete anything from those columns, and then the Excel won't plot that on my graph. So that's a little bit of a manual, not very quick way to do it. So hopefully my graph's not plotting up that big gap now. I'll just go back and have a look. Yep, see, now you can see it's showing that as a gap. It's not plotting it as zeros. But that's a bit of a manual way. The other way that we talked about in week 1 is, I think it's under format chart area maybe. Hang on a sec. Formats. no, it's select data. So you right click on your graph and go select data, and then see here how it says hidden and empty cells. You can click on that and set what you'd like the empty cells to be shown as. So at the moment it's looking for gaps. So that's why I've deleted the data and it sees that as a gap, because even if there's a formula in your cell, Excel sees that as something. So it's plotting that as a 0. That's why I had to delete my formula to get it to plot as a gap. But you can, I thought there was an option here to put it as an NA. We did that in week 2, I think. Show data and hidden empty cells. Maybe that's because I deleted it.
But this is pretty handy.
Yeah, I'm pretty sure hidden and empty cells. Now this might be because I'm using my other laptop because my normal one died and it's not giving the same option that it did when I did it in week 2, but it had a tick box for show empty cells or treat hashtag NA as empty cells. So hopefully you might be able to find that on your own Excel where there's an option that you can tick the box, and if you've got hashtag NA, then it sees that as missing. So that could be another way to do it. There are obviously better ways than the way I've done it, but I just wanted to show you there how it was plotting as a 0, but I went and deleted it and made sure it's plotting as a gap there. But at the moment, I haven't deleted the other gaps that are there, so they'll be connecting. I also had a go at just plotting some histograms to have a look at data fitting within various categories, but I did it in a hurry and it's actually plotting 2 different plots for the sites with different categories. So that's not very good comparison really. If I was doing it better, I would set you have to tell Excel what the categories are if you want them to be certain categories. Otherwise it just does an automatic and it set different categories for the different sites, which makes it hard to compare the 2. So then for the cumulative frequency curve, I think I already showed you my curve, but this is, I'm learning to control this mouse. This is the curve that I got just copying across from Tony Ludson's, and I told you that I couldn't get the x-axis to plot down the bottom, it's plotting up the top, which is silly of me. I just couldn't figure that out. But the task asked you to look at the proportion of time that total phosphorus concentrations are greater than 0.02. And so we can just put in a horizontal line, for example, or you can just visualize a horizontal line and then go to your x-axis to read off the proportion of time that concentrations are greater than that threshold.
Yeah, so to iterate on like what you said, Emily, like the hashtag NA, like I managed to find some of the I managed to find it in my version of Excel. So I might just share my screen.
Oh, thanks, Tim. That's great.
Yeah. So are you viewing like this one? Yeah. So if I click on select data, I think this one is the 2019 version. Yeah, and then like for mine, it's right here, you know, like show hashtag NA as an empty cell. Yeah. So I think it's this one.
That's good. I'm not going crazy because I was wondering what had happened to that option.
No,
I think I must have an older version on this laptop that I'm using today.
Yeah.
Thanks, Tim. That's reassuring. I felt really stupid that it had disappeared.
No.
That's awesome.
Yeah.
That's handy. Thank you.
Yeah. So I think that thing is actually pretty cool and pretty handy.
Yeah, I think that is handy.
Yeah. Okay, so can we get like some comments on where are you guys currently at?
Or if you want to write any questions, even just why are we doing this? What's the point? If you're wondering, you know, why it's important or anything like that, we can talk about that. Well, we've probably already covered that a bit. Is there anyone looking at doing a moving average to have a look at the trends in the data and the time series? or using pivot tables to work out monthly averages.
Nãy làm gì la vậy? Hả? Đau, trời ơi đau. Cái gì hả?
Vô mắt cái gì vậy thế?
Ngồi biết rồi quá.
Hả? Ruby.
So I think the cumulative exceedance plots are a really useful tool in water quality, just like they are for the flow data. Very often we're looking at comparing water quality to guideline values, so it can give you a quick understanding of how often concentrations are above or below a threshold. So for many parameters, it's a problem when they're higher concentrations. So we're often looking at how often are we above a certain threshold given in the guidelines, for example. But some parameters like dissolved oxygen, they're a problem when their values are low. So in that case, we would look at how often is dissolved oxygen below a certain threshold. This is the thing about cumulative exceedance plots is though it doesn't tell you anything about the sequencing of the data. So for that, you need something like a time series where you're looking at how the concentrations are changing over time. So for certain impacts like maybe it might mainly be a problem if we have low dissolved oxygen in a certain season. So I shouldn't use that as an example because low dissolved oxygen would be a problem whenever it occurs, but perhaps the ecosystem might be more sensitive at certain times of the year, perhaps when the fish are spawning, for example. So you might be interested in water quality a certain time of the year. So a time series might allow you to have a look at when we've got poor water quality occurring. But you could also do a cumulative exceedance plot on a seasonal basis. So you might do it just for certain months or the months of spring, for example. Yeah, so that's why we're using a whole range of different graphical tools and statistical tools to investigate our data, because each type of graph has benefits, and then there are other types of graphs that have different benefits or potentially disadvantages as well for the information it gives about our data set. Like box plots are really good for looking at the spread of the data and how it's spread about the median value and identifying outliers, for example, and how much of the data is within certain ranges. Cumulative exceedance plots also allow us to have a look at the spread of the data and how much of the data is above different thresholds. And then time series. It's really important. I think you always plot a time series because that shows the sequence of the data. It's and how it's changing through time as well. I think when I've done data analysis, it's very easy to just charge ahead and not even do the simple step of plotting up a time series. But sometimes as soon as you plot a time series, you can really easily spot something about your data that might ring alarm bells, or it tells you a lot about the data set. And it's a pretty simple step to plot it. When you have big data sets, you might need to, zoom in on your time series to be able to identify certain things. Maybe when you've got a really big data set and you're zoomed out, you can't really identify what's going on a smaller time scale. So the ability to have a look over the longer time scale and then shorter time scale at what sort of patterns are going on in your time series can be important as well.
Yeah, Emily, I do agree with you about that. So let's say, so like for my example, so I noticed that sometimes, like flow data, it just went haywire, but you are plotting across a year worth of data, so you can't really see that. So in order to do that, you would need another plot which really like just look at those small periods, so you can see any like even small bits of changes, in the flow data. So I think this step is very, very important. Yeah. And also like just now you mentioned that like every plot has its benefits and its limitations. So I think a very good method to see like what plots to use is actually like what analysis are you trying to conduct, like what are you trying to investigate. So let's say if I'm trying to so let's say my purpose of doing all this analysis is to investigate like which like the seasonality, like temporal variation. So I think in this case I would just go for like time series plots, or maybe like a monthly column bar chart. Yeah, just to check on the temporal variation. Whereas if you are trying to check on the percentiles, so I think that for that one, it's a good thing to use the cumulative accidents plots, because you don't really care about when does it happen, but you really care about at how, like, what are the chances of occurrence like for this value. Yeah. I think like thinking about the purpose of doing all this analysis is pretty important for you to understand like what graphs to use.
That's a really good point, Tim. Yeah, definitely making sure that you keep your mind on the end game of what you're trying to do as well. Yeah, as well as using a range of graphs to make sure you're picking up on any kind of behavior in your data that it's important that you're aware of. Yeah, that's a good point. Maybe I should mute. I can hear the kids screaming. Sorry, everyone. Yeah, that's a good question. So I've been asked anonymously whether we'll upload the prac solutions, because it is a bit of a time consuming task, and you might want to check how you're going with it. It's a really good point, and I'll check with the Malaysian lecturers as well what they're doing. But I think I don't want to just upload it necessarily, because it's part of what you need to do for assignment 2. So I do want you all to sort of be able to do it from scratch. But I will talk to the Malaysian lecturers about that. It's a good question, and I will ask. But I'll definitely make the recording available as well. And as well, if you have questions with it, come to the Thursday help desk as well, and you can share your spreadsheet, or I can share my spreadsheet and talk through any of the aspects as well that you're still having trouble with. And also, the way I've done it in Excel is probably not the best way. You might have better ways to do it. So I don't want everyone to think they have to use the formulas or the layout or the graphs that I've used. Some of them I haven't even used that very well, like the histograms. So it's a good question. I'll try and follow that up. Is anyone having any trouble doing any bits, like even that summary table of how to develop that summary table of what proportion of your data is each of the quality codes? If you're really stuck on any of these bits, let us know, or send me an email afterwards, or come on Thursday and we can talk through it. It's a bit hard, I know, in front of everyone, and it would be better if we could be all in the computer lab together or something and walk around and talk to everyone about how they're going. So I know it's a bit tricky on Zoom. I just do want to help if anyone's stuck. So maybe about 10 minutes, we might try and do a discussion of what, no, less than 10 minutes, maybe about 5:40. We'll do a bit of a discussion about what kind of trends anyone might have seen in the data. Why do you think there's differences between these two sites, Valencia Creek and the Avon River? If you go to that Water Management Information System website where the data has come from, and you could look up the two sites pretty quickly, have a look at their catchment areas, maybe have a look at the map showing where these sites are, and have a think about what could be causing differences in total phosphorus between the two sites. Maybe before we do that though, we could do a demonstration of pivot tables again, do you think, Tim, for anyone who wants to tune into that? I know this morning we just really briefly before the discussion did a little pivot table.
Yeah, so yeah, I can do that. So
I think you're so much better at pivot tables than me, but I did put in a couple of pivot tables in that spreadsheet.
Oh yeah, I think we can demonstrate that
on that tab.
Yeah.
I'm happy to have a go talking through that. Yeah, that monthly averages tab. It's the final tab.
Yep. Yeah, sure. I think I will let you go.
Yeah, sure.
Yeah.
I haven't probably done it the best way.
No, I think it's actually a pretty good one.
It's all right.
Yeah, it's all right. It looks pretty good. Yeah.
So to do a pivot table, you just need to highlight the data that you're interested in. So where did I initially do it? So I would have highlighted my data here. I wonder if I pasted it somewhere separate to do my pivot table. But say, for example, I'm trying to do a pivot table with this data. It's probably best if you have your data side by side with the dates, and it's easier for then putting in your pivot table. But then you go insert pivot table there, and then it gives you an option where it's going to place the pivot table. So whether you want to do it in a new worksheet or in your existing worksheet, and then you can say where you want it to drop the pivot table. Okay, so I did it in a new worksheet, and I've got this spreadsheet here. So I just put into my pivot table, I highlighted data where I had my Valencia Creek data and my Avon River data. Now the first pivot table I did here, it's just doing the months. So I've done it a bit wrong there, because what I really want is I want an average total phosphorus concentration for all of the Januaries in the data, and then all of the Februaries, if that makes sense. So over here, I did better pivot table here, where so when you're doing pivot table, you'll get this pivot table fields thing come up at the right hand here. And so you can just play with your with what values you drop in. So I've put months in for my rows, and then for my values, I've selected average values. So very often when your pivot table comes up, it will automatically sum the values, and you always need to just stop and have a think. Okay, what am I trying to do with my pivot table data? Do I want it to sum up all of the total phosphorus data for all of the months of January in my data set? And I think about that, and I think, no, I don't want it to sum up. I want to know the average concentration for January, for February, for March. So to change what it's doing, you go value field settings, and you can change between whether it's summing the values or counting the values. So if you want to count of all the data for January, for example, you can do that with the pivot table. But in this case, we want an average, and you can even also get the maximum and the minimum values. So that's really useful. So you just need to remember to change here so that it's actually doing what you want it to do to get the data out of it, the right data out of your pivot table. So I just did that to get the average, and then often I don't think you can make graphs directly from your pivot table data, so I just copy it and drop it again here, copy and paste it here, and then I've done a column graph here, plotting up the average total phosphorus for each of the months. You know, ideally I'd probably label it better than 1 to 12. I'd put in Jan to December, but that's how I got that plot there. Tim, do you have anything to add to that? Because you are better at pivot tables. I think actually what I did, and I didn't describe it very well, but to get that month column on its own, did I use this data first? I did it a while ago.
I think like you have like month, like your rows is like month slash something. I think you can change that one.
Yeah, so I think to get it to do the month, do you have to have a column that just pulls out the month from your date?
I don't think so. I think it's.
Or the pivot table can do that. It can pull out the month. Yeah. I just forgot if I did that, if I maybe in my data set went back and put in a month column that's pulling out the month so the pivot table can reference that, or it just does that itself.
Yeah. But I think if you are doing pivot table and you can't seem to find that option, then just go for like, just extract the months, because it's not really a tedious and difficult process. It's just extracting the months. Yeah.
You can use that month formula, for example, that I showed. So where you go equals month, and then you refer to your date column, and that will pull the month out of your date. So that can be useful when you're trying to do some sort of analysis where you're pulling together. And the same with if you do equals year, and you refer to your date column. Yeah. And for the trend analysis, so there is that example spreadsheet of the moving average, and definitely have a look at the slides there that I talked through at the start of the prac class. So for example, here I've done just a 5-month moving average just by looking at an average over a 5-month window, and then we roll that down, and our average just moves down. The window that we're calculating that average over just moves down with the data. You can select the period over which you select for your moving average depends on the question you're trying to answer, and depends over what kind of time frame you're looking for your trends. So you're trying to smooth out the data just enough so that you can see longer term trends. So if you're looking over a really long term, you might do your moving average over a longer period than if you're just trying to see what trends there are, maybe seasonal trends over a shorter period, for example. And also did a 12-month moving average just using the formula Tony Ladson did in that example spreadsheet, where he's taken an average, but he's used these weight factors to try and take that emphasis off the first and the last value, for example. So there's different ways you can do it. And then I've just got, that's my time series plot, but then I did plot out my moving averages, and I shouldn't have done it over this gap in the time series, so that hasn't plotted very well. I think you guys can make better plots than what I did, what I've done here. But it's just trying to smooth out those fluctuations so we can have a look for longer term trends, whether in general it's increasing or it's decreasing there.
Yeah, well, I think that is a pretty good one. Like the concept of moving average. Yeah.
And I think where there's that gap in the data set, you obviously don't want your moving average calculating over that gap. And I think I made a mistake there where I did it in a hurry. I filled it down, and I haven't even scrolled down to where the gaps are to probably delete my moving average calculation for that period, because it's going to start moving into the missing data period. So I'd probably just not have that as a gap in my graph. So here's a question. Yeah, that's a good point. And I think the weighting of moving averages is not something we'd want to do, because it's putting an interpretation on it. Here, we have just weighted the first and the last values kind of equally, and I think that's not having any impact. But you can, I think in economic analysis, they use moving averages quite a lot, and they might do certain weightings where they're putting emphasis on the recent data. So that's a good question. I haven't seen a reference that gives a description of when you should maybe do weighting or not. I recommend not doing weighting unless you maybe just use Tony Ladson's example to use that weighting of the last values, but you wouldn't want to do any other type of weighting, I think, where you're putting more emphasis on different values. Not for our purpose, where we're looking at it, just analysing our data, having a look at what trends are there. I think you would use weighting in an economic sense when you're looking to forecast and you're trying to put more emphasis on the recent data. But that's sort of beyond the scope here of what we're doing. It's just sort of the broader use of moving averages. So in our case, we're probably more interested in trying to think about what period over which to do the moving average in the first place. You know, how many months, for example, to incorporate there. And you could have a play around with it, try calculating moving average over a different types of time periods and seeing what it's showing you on your graphs. It's a good question. We aren't expected to do weighting? No.
No, just a normal moving average.
Yeah. So you can just calculate it the way that it's shown in the PowerPoint slides I shared with you, or you can use Tony Ladson's example there. What's more important, like I just said, is just thinking about what period over which to calculate the moving average. And then interpreting what it's showing. So that's what's more important for our assignment. So since we're up to 5:43, we might talk about what the data is actually showing us. Does anybody have any insights from what they've done, even just, you know, a comparison of the two sites? What kind of patterns are you seeing? Has anybody noticed any differences, and they're thinking about why that might be the case between the two different sites? Okay, so which site tended to have the higher phosphorus concentrations? Anybody have a look at their plots and see what's going on there if we do a comparison? So you should be able to see from your plots and your statistics as well, if you're looking at median concentrations, that we have higher total phosphorus at the Avon River site compared with the Valencia Creek site. And we can see that pretty consistently with our different types of plots. We can see it on a time series plot, although we do have some spikes in phosphorus concentrations at Valencia Creek that we're not seeing at the Avon River site. So it's not always higher at Avon River site, but in general, it's fairly consistently higher. What else did I notice? In terms of the trend analysis, I couldn't see any obvious trends, but the seasonal average total phosphorus concentration did seem to show that, hang on a minute, I should share my screen maybe and just show the graph. Okay, so if we look at our seasonal average total phosphorus concentrations, we can still, this also shows that we've got higher total phosphorus in general at the Avon River site, lower at Valencia Creek. We can see at Valencia Creek, there's probably more consistency in total phosphorus between different months. We're not seeing as much seasonal variation there. We're seeing generally higher concentrations though in August.
Probably it's a seasonal effect, a temporal variation.
What's that? Sorry, Tim.
So probably it's a seasonal, like a seasonal pattern. Yeah. So like we can observe, like during winters, we can see that like the total phosphorus, the concentration is slightly higher, if not the same as the Avon River.
That's a good point.
Yeah, while for the Avon River is actually it's the opposite, like it has a higher concentration is at the other months except for winter.
Yes, yeah, that's a good point and some good trends. I think you can often see some interesting patterns from looking at these types of plots, particularly when we're looking at the seasonal values and some good seasonal trends. Sorry, so that's some good observations that Tim just made. And so yeah, we can see that at Avon River we have particularly high phosphorus in March, but also in sort of the summer months. Whereas at Valencia Creek, it does look like the opposite, where we've got the higher concentrations in the winter months. So we could think about the two different sites there, have a look at what information you can gather on catchments, the land uses in the catchment. So we talked about that in the lectures, that land use is a really big driver in terms of the sources of nutrients that are available as well. We can think about different seasonal activities within those land uses that are occurring. So if you went to the Water Management Information System website, you can see the catchment areas of these sites. And I've just had, go back to my notes here. So the Valencia site catchment is 195 square kilometres, whereas the Avon River catchment is much larger. So it's at 1,485 square kilometres. So we've got a much bigger catchment. So we'll have different dynamics going on. In that larger catchment, we've probably got a range of land uses in that area. If you have a look at the map, I think it shows Valencia Creek looks like it's a bit more of a forested region, and it's that smaller catchment. Whereas Avon River catchment, we're sure to have big agricultural areas within that catchment. So probably those monthly patterns in terms of total phosphorus, probably indicating some sources within the catchment. So phosphorus, a really big source can be fertilizer use. So perhaps in March, and also for phosphorus, soil erosion is a really big driver as well. So it might be the case that in March we have certain agricultural practices occurring. Usually perhaps it's at the end of a crop rotation, there might be bare soil, it might be conducive to more erosion processes occurring and putting phosphorus into the stream. Or it could be perhaps during crop planting time and there are fertilizers being used as crops are being planted as well, that are then making their way into the stream. So there could be different processes going on there. And to get a better understanding of that, you can gather some data and information about your catchment and have a think about land uses and the different management practices within those catchments. So that could be a reason why we're seeing those different patterns between those sites. I think that was the main point to think about in terms of comparing those sites. Does anybody have any other comments they wanted to make about their data or why there might be differences between the two sites? So definitely looking to the catchment and having a think about the key sources, and land use is such an important driver there. So yeah, Valencia Creek forested catchment versus Avon River, where you'll have lots of agriculture, probably quite a number of towns as well, so some urban sources of nutrients as well, with stormwater runoff from those towns and urban areas as well.
So Emily, so a question from me. So do you think that the location of the catchment, so let's say, so because I'm not sure like which one is downstream or which one is upstream, so do you think that this will pose an effect on the TP concentration?
It's a good point, Tim. I actually didn't even I only really quickly looked up where each of these sites were, and I'm not sure if Valencia Creek sits within the Avon River catchment or if it's a separate larger catchment area of a different river system. So it's a good point, and it's something that you could, it's definitely important to think about if you were doing a proper, more detailed analysis of these sites. And it could be that Valencia Creek is upstream and a small sub-catchment within the larger Avon River catchment, in which case it's a really interesting comparison of the types of concentrations and patterns we can see in the upper parts of the catchment, which might be forested, versus lower down in the catchment where we've got a big catchment area, a diversity of upstream land uses like the agriculture. And that's a really good point to then lead into talking about assignment 2. So it's a really good question there. Let me just open it up because we've got less than 10 minutes to go. I better move on to assignment 2, and it's good to keep in mind. Thanks, Tim. That's a really good question. So for assignment 2, the brief's up on Moodle. It's pretty similar approach to assignment 1. So working in groups again. If you'd like to change your groups because you're in just a group of 2, for example, and you're looking for a new member or maybe looking to team up with other people, just send me an email, please, because otherwise I won't know that you've changed groups. Don't just change that online spreadsheet because I've already entered groups into Moodle. So definitely send me an email if there's any change to your group members. Otherwise, let's have a bit of a look at the brief of what we'll be looking at in assignment 2. And we've already covered quite a bit of the material to allow you to get started. And what we were doing today is directly relevant. So hopefully that's a bit of a head start. So we're talking about, so Melbourne Water collects water quality data at over 130 sites across the Yarra River, the Werribee River, Maribyrnong River, Western Port Bay and Dandenong Creek catchments. So that's a huge area, some major river catchments, and they all drain into Port Phillip Bay or Western Port Bay. But the largest of these catchments is the Yarra River catchment, and that's going to be the focus of our assignment. So the total area of the Yarra River catchment is around about 4,000 square kilometres, and it lies to the north and east of Melbourne. And we've got a figure here just showing the catchment there. Okay, so across this catchment, it covers a diversity of land uses. I can see there's a question in the chat.
No, it's just Nafisa asking, like, the location of the catchment. So would it not affect the results if water flows from the other catchments? Yeah.
Or what do you mean?
Like it flows from the other place, but so what I'm thinking is just that, like, the catchment has already been delineated, so it's actually so it actually goes to right up to the upstream, like according to the digital elevation model, like the height of the ground. So actually everything has already been delineated, so it won't be affected by the other catchments. They won't affect each other.
Yeah, I guess the way that water flows out of catchments depends on the topography. And is that what you're saying, Tim? And it's
yes, topography.
Yeah, it's a good point. Sorry, I couldn't see the chat and read the question.
That's all right.
Okay, so within our Yarra River catchment that we're looking at for this assignment, we've got a diversity of land uses. So in the upper parts of the catchment, just like we were just talking about then, we've got forested areas in the upper reaches of the Yarra River. And then moving downstream, the river moves through agricultural areas where we've got different farming activities. And then further down in the lower reaches, down near, within Melbourne, we've got the city of Melbourne and the suburbs of Melbourne that the river flows through. So in the lower reaches of the river, we've got dense urban development and industrial areas as well. So it's an interesting catchment because we've got this range of land uses, and we sort of have this gradient from the upper parts of the catchment moving down to the lower parts. Okay, so the focus of this assignment is going to be on the lower the lower freshwater reaches of the Yarra River. So we're talking about upstream of Dights Falls. So you might not be from Melbourne, you might not have heard of Dights Falls, and that doesn't matter for this assignment at all. But Dights Falls is located here. Hopefully you can see my cursor here. So it's in the lower part of the catchment, and that is the point where the tidal influence on the river stops. The tide cannot go above Dights Falls because it's a natural waterfall there. So upstream of Dights Falls, it's all fresh water, whereas downstream of Dights Falls, there is a saltwater influence because there's a tidal influence on the river there. So we're just focusing on upstream of Dights Falls, which is the freshwater part of the river. Okay, so we've got a map here that indicates about the catchment there. So as part of managing water quality into Port Phillip Bay, because the Yarra River discharges at its outlet into Port Phillip Bay, so Melbourne Water needs to manage the quality of water within Port Phillip Bay. And obviously it's very important to the quality of Port Phillip Bay is the quality of the water coming out of the Yarra River. So Melbourne Water is commissioning a study from your team to review the performance of its water quality monitoring program. And you also need to model the behaviour of a key pollutant and assess water quality and develop recommendations for future monitoring. So initially, your review will focus on one site, and that's the Yarra River at the Chandler Highway. And so at this point, the Yarra River has a catchment of approximately 3,290 square kilometres. So there's a number of deliverables that you need to complete. So the first one revolves around checking the quality of your available data. So that's why this week's prac was really important to that first step. So there are a number of suggested tasks, and just like the first assignment, you can choose to do additional tasks that you see are relevant to meeting that deliverable. So these are just suggested tasks, but you can go beyond that, and the marking rubric will indicate if you need to go beyond that for getting the top mark, for example. So for the first task, checking the data quality, you can look at identifying the proportion of data that's poor quality and how it's distributed through time. So some of that we talked about today. Having a look at whether the data are physically realistic, whether there are periods of strange behaviour in the data, so looking to identify that. And then a discussion of whether you should include or remove any suspicious and poor quality data. So as a result of your data checking process, you need to then create a checked and clean data set that you can then use in the other deliverables. So you can't really just start doing deliverable 2 until you've done deliverable 1, where you've checked the quality of the data set and you've provided this clean data set that's ready to use, that you've checked the quality, you've dealt with any suspicious data, you've either decided to include it or exclude it, and you've done all of that analysis that we focused on today. Deliverable 2 is identifying temporal trends in water quality in the river. So looking at how often and when water quality exceeds water quality guidelines. So assessing the water quality at that location. So you can do things like prepare time series plots and have a look at temporal trends, look at some plots to identify seasonal behaviour in water quality and also in flow, because flow is a big driver. Flow and water quality are really connected. Flow's transporting the pollutants into the bay, and a lot of pollutants are transported during high flow events as well. So you need to find the appropriate water quality guidelines to do your comparison against, and discuss any limitations with the data as well. Then deliverable 3, we're looking at predicting sediment concentrations in the Yarra River, looking at how sediment concentrations can be affected by future stream flow. So we'll be developing a model, and that's going to be a build-up and wash-off model to model sediment generation within the catchment. So we need to calibrate and validate that model and assess how well the model's performing, using one or more objective functions and other performance indicators like what we've talked about in the lectures, like different plots to have a look at how well your model's performing. You need to do a sensitivity analysis of each model parameter, discuss the limitations of the model, and also use it to discuss the likely range of sediment concentrations in the future. And then deliverable 4 is proposing a sediment management plan for the Yarra River at the Chandler Highway. So that can include discussing some management strategies recommended for suspended sediment in the river, identifying whether it's feasible to implement management strategies within the catchment, and also considering a broader perspective in terms of economic, social and political perspective as well. Propose how Melbourne Water could validate the success of these management strategies. And then there's just some information about the report and the length of the report that you need to provide. So some of this content you can already start with, because we've already talked about data checking and data analysis. Some of the other steps, like the deliverable 3 for the build up and wash off model, we will provide some more guidance in the prac classes as well to help you through that as well, and doing the sensitivity analysis. So we will work on some of this, give you some tips on how to do that together as well. In the appendices, we've got the marking rubric, just like the first assignment, but also the final appendix is some information on the build up and runoff model. Sorry, I'm not scrolling very well today with my mouse. So some information on how to do the build up and wash off model. Next week, we're talking about water quality modelling as well. So you should get a bit more information to help you deal with that task, to do this task. And we'll also help you with some tips as well along the way. So That's the second assignment, and I recommend you do start early, particularly with those steps that we've already covered and that you can do, particularly while today's prac's fresh in your mind as well, starting on doing that water quality data analysis.
Especially on the water quality, like the data check, because that one will influence everything.
Yeah, you can't sort of go ahead until you've got that cleaned, checked data set. So you're right, Tim. Good to get that out of the way, and particularly so we've got the 2-week break coming up as well. So if you can at least get that step done, it might make dividing up between your team members of who's going to do some of the other deliverables easier if you kind of work together, get that done, and then on the 2-week break you can sort of be working on some of the other tasks as well. So thanks so much everyone for your time today and work and effort doing that data checking exercise, and I hope that it will be helpful for the assignment. If you have ongoing questions, I will hang around at the end of this as well, and there's also the Thursday help session, or feel free to send me an email and I'll aim to upload the recording as well if you want to refer back to anything. Does anyone have any other questions? Otherwise, I wish you a good evening and I'll see you next week. Thanks very much, Tim.
All right, thanks so much, Emily.
Thanks. Sorry, look, we all went sort of almost over time a bit. Thanks, everyone.
That's all right.
That's very kind. Always seems to happen. I should leave a bit more time for going through the assignment brief.
No, it's actually pretty okay. Yeah, it's pretty okay. Yeah. So are we meeting tomorrow?
Yes, I'll send. I'm sorry I hadn't sent a meeting invite. I was a bit busy for today, but I will send a meeting invite. Is there a time that suits you better?
No, I'm free like anytime. Yeah.
Okay. Okay.
The rest are also the same. Yeah.
Oh, are they? Oh, they've sent emails. Okay, I haven't checked. Sorry,
I
should have sent an email last night. I just was doing all the lecture preparation and the prac class preparation, and next week's getting that all up in the past couple of days as well. But yeah, I'll send a Zoom invite tonight. Okay. I'm meeting with the Malaysian lecturers. We always meet at 11 on a Wednesday. So I don't know if it's better if we meet before or after that.
Maybe after for me.
Okay. Yep. Yeah. Okay. All right. I'll send an invite, and if it doesn't suit, let me know.
Yep. Sure.
Thanks so much, Tim.
All right. Thanks so much, Emily.
Have a good evening.
All right. You too.
Thank you. Thanks.
See you. Bye.
See you. Does anyone have any questions I can help with? No questions from anyone still here? Don't be shy. Thanks, Sophie. Thanks. Thanks for your great question. How are you, Annie? Can I help with anything? Okay, all right. Well, I might end the meeting, and if you have any other questions, just get in touch or come to the Thursday session as well. Thanks, guys.